Okay, now this is discussing a statement and some information you're given to do with ionization energy. And it's just really recognizing basic trends that, for instance, one of the most important ones is the number of protons, the nuclear charge, and determining how tightly electrons are held, and also which energy level they're in, how far they are away from the nucleus, which is also tied in with the amount of electron shielding that goes on, because if you add on orbitals, you're adding on more and more electron shielding as well. And also the third thing would be the amount of repulsion between electrons. That can be a factor as well. So when we look at losing the first electron here, that now doesn't take much energy. It's further away from the nucleus, and it's going to be held less tightly, this electron. Therefore it takes not a high amount of energy to remove it. Ionization energy is always endothermic. It always takes energy to remove one. Now the second ionization energy is much larger, and this is something you'd be expected to comment on. Obviously, we've got the same number of protons, but because we've now dropped down on energy level, we've now got basically it's a closer distance, there's less electron shielding, therefore the electrostatic attraction that there is for that next electron is much greater. Therefore it takes a lot more energy to remove that electron. Okay. Now finally, for the second to third one, well, there's an increase in energy here, and it's not a huge amount, but it is a increase, and we're removing an electron from the same energy level, and when we do so, obviously there's going to be less electron-electron repulsion, and that means as we go across, electrons are going to be held tighter. There's no change in the number of protons. It is the same energy level, but with decreased electron-electron repulsions, it does get harder to remove these electrons as we go across, because we get a greater attraction as we go across the period. Okay, so if we discuss this relative to those, we should have a good answer.